Good morning. Great. I called it prep questions. So those prep questions, we can work on some of them. I got some detailed email from some students with questions, so we'll look at those as well. And you can let me know if you have any additional questions. I sent you, I'm just looking now at my list, I sent you the solutions for everything, really, except for those and this one that I wanted to look at. So I'm just waiting for people to enter. Why am I losing people on the chat? I wonder. Let's just wait a bit. Who's here? Do you see the chat? So you're writing here. I can't see in the control room, but I see you now. So it's 15 of you. Good morning. You can't hear. Can you hear now? Okay, I can see the chat. Can you hear me? Okay, very good. Yeah, maybe I wasn't talking or you weren't getting the feed. All right, so looks like we're almost ready to go. So all that I was saying is that I gave you the solutions for almost everything. I'm going to focus today on this handout, which I didn't give you the solutions for, but I will share with you because it can get very detailed and messy in the presentation. And then also the prep questions, the test prep questions. The test prep questions, I am not going to share my official solutions with you, but we can work on solving them together. And then questions like those will appear on the test. I'm going to give you 10 questions on the test, and you have to answer 8 of them. So you get some choice, all right? That's how I'm going to have this is how the test will be tomorrow. So questions like the prep questions, I'll give you 10 and you have to answer 8 and submit them to me before 6 p.m. Okay. Very good. So for the practice assignments, if you want to send me your solutions, I can tell you if they're correct or not, okay? But I can't give you everything because I need to keep some for the tests, right? But if you have the right answer or the right approach or almost the right answer, I'll let you know. So you can work on them and send them to me. Let's see. But remember, the questions are not going to be exactly like those. So you need to understand the approach. It can't just be copying because obviously I'm going to give you different questions with different, slightly different questions. Different numbers, of course. Okay, discounting and inflation solutions. How did you do? Did anybody work on this? Prepare something? So you need a couple of formula to do this. Usually I teach this later, but next week will be the later, so might as well introduce it now and familiarize you with this topic. I'm just organizing my page. How many people are here? So we have 21. All right, so let's start. Okay, so this says, suppose hold on. Suppose the nominal discount rate is 8% and the expected inflation rate is 2%. Determine the present value of a 6-payment annuity of $1,000 in real cash flow per year. The first payment is in 1 year. All right. So we have some terminology maybe you're not familiar with. Maybe some of you are. What is a nominal discount rate and what is inflation? So until today, until this discussion, all the rates that I give you, well, we've distinguished between stated rates and effective rates. That's what we focused on yesterday, and I introduced the day before that. Nominal discount rate is also an interest rate, and it's the term that's used to, it's another way of saying the same thing. Okay, so this is treat this as this is an effective rate because I haven't said anything. So this whole page, these are effective rates. Let me make a note. The rates are effective, but the distinguishing thing today is going to be between real and nominal rates. Okay, so this discussion is about real versus nominal. So you would have learned about this in 3107. I'm not sure how much you talked about it in 3106, but if you took economics, you would have heard about real and nominal rates. And in this class, we are going to distinguish and be very precise about what we're talking, what we're talking about. This is supposed to say real. Let me make it bigger. That's an A. Again, I'll send you the clave, I'll send you the solutions all typed up really neat. All right, so the distinguishing feature is real versus nominal. So you need to know a couple of things. Well, what's the relationship between real and nominal? Does anybody know? Mathematically. Yes, this material will be could be on the test on Saturday, Luis. But if you see it on the test, it'll appear like this. I'll mention if a rate is real or nominal. The point is, this is an exercise in annuities. So what's the relationship between real and nominal rates? So if I use a notation R for real rate and Rn for nominal rate, what is the relationship you know? Okay, so Alfonso says it's the nominal rate is equal to the real rate with inflation. Oh, sorry. With inflation. We use the symbol for inflation. You got that? So this is the real rate, this is the nominal rate, and this is saying that the real rate plus the nominal, plus inflation is equal to the nominal rate. In fact, this is what you learn in economics, but this is only an approximation. This symbol here that I put means approximation. So the nominal rate is the real rate plus inflation. So the real rate doesn't have it removes the inflation. Okay, so it shows you if there's been real growth or real increase in the rate, regardless of the changing inflation. What's inflation? That's the effect that we recognize as a change in prices, all prices going up. So this actually is just an approximation, and it works when the inflation rate is small. Okay, it's a good approximation when the inflation is small. So because of the central bank operates in tandem with the government to control inflation, and they target to keep inflation low. So that's why this equation works. But in fact, it's not. Rates all have compounding effect. It's not an additive. It's not a multiplicative thing. It's a accumulation factor effect. So really, it's not this relationship that's the precise relationship. It's this one. That the rate 1, or the factor 1 plus the nominal rate is equal to, I don't have enough room there. So 1 plus the nominal rate is equal to 1 plus the real rate with a growth factor of inflation. So these are all rates, and this is the most important thing to describe to you. Okay, so that's the precise relationship between nominal and real rates. So what I'm doing here, if I wanted to deflate the nominal rate, in other words, I want to solve for, let's say, the real rate, then I can use this relationship and solve that the real rate, just bear with me, hang in there, I think you understand. If I solve this, the real rate is a factor of the nominal rate. I'm going to make this bigger so then I can write more. So let's do it like this. So now we see that the real rate is a matter of deflating the nominal rate with factors. You see? So now that looks more familiar to what we've been doing this week, in that I'm working with the factor effect, the accumulation factor. Okay, so this is so this is the relationship between them. The other thing you need to know, so everybody's okay with that? Either you can solve for the nominal rate from the real rate and inflation, or the real rate from the nominal rate and inflation, depending which one you want. Now, which one will you want? Well, if I gave you cash flows that were nominal, you would need to use the nominal rate. If I give you cash flows that are real, you need to use the real rate. So this might be new information to you. So what are nominal cash flows? What are real cash flows? Nominal cash flows and nominal rates are the things we've been working with so far. Okay, that's what people operate with. But there may be an occasion where you you receive cash flows, or you receive information like in these exercises, you have been promised cash flows that are adjusted for inflation over time. So either they'll tell you the cash flows in nominal terms, so the actual adjustment with the indexing or the, the accounting growth with the growth factor for inflation, or they will give you the real amounts and promise you that you will receive the purchasing power, the equivalent purchasing power every year. That's what real dollars are. So for instance, let's just draw the timelines for two of these, and then so for here, you're told about this regular annuity. This is a regular annuity versus, the growing annuity. So this is 6 payments of $1,000 in real cash flows. So what that means is, in real cash flows means that I will retain the purchasing power of $1,000 today for the next 6 payments. So whatever I can buy, let's say if I can buy some sort of laptop for $1,000 or an iPad for $1,000 today, then I should be able to buy the equivalent iPad in a year, and then for the next 6 years. Okay, so you will be given enough money to compensate you for the equivalent of $1,000. That's real cash flows. So then, if you made that as a timeline of regular cash flows, or regular annuity, it would just look like. Okay, wait. I'm gonna let you write this out, and I'm gonna delete this So write out the formula. Which formula? You have 2 versions, right? There's this version and this version. They're the same formula, but just different things I'm solving for. So you would have to take the 1 off here, right? If you want the nominal rate. Maybe I'll put it beside so it's not so confusing. So from that relationship between real and nominal rates and inflation, you get these 2 formulas. All right. Okay, so now let's make the timeline. So the timeline of 1,000 Okay, so you're going to get, they're told $1,000 for 6 periods. 1, 2, 3, 4, 5, 6. Very messy, but maybe you can make yours neater. Okay, so these are real cash flows. So you're going to get $1,000, and what $1,000 can buy today, you're going to get it for 6 periods. So what I want you to do now is make the timeline in terms of nominal cash flows. I'm going to make it bigger. I need more space. I'm having this one more time. Okay, so those are 6. Okay, so in nominal terms, what am I going to have? I have to be able to have the purchasing power of $1,000 at year 1, the purchasing power of $1,000 today at year 2, 3, 4, 5, and 6. So what will those look like? So the first one would be 1,000 with adjusted for inflation. And inflation in this exercise is 2%. So the first cash flow would really be $1,000, $1,020. So that's really what you would, that's actually what you would get in your pocket, okay? If someone promised you real dollar value of $1,000, then they promise you 1,020 to account for the 2% inflation. And in the next period, it would be two periods of inflation, right? Exactly. So you understand that this will be higher and higher, and the last one will be right, because it goes however many periods of inflation have occurred or transpired determines the exponent each time because of the way this problem was written. So these are the real cash flows. So if you solve this problem in part A as an annuity with the real cash flows, the point is you need to use the real rate with a regular annuity. If instead you want to use the nominal cash flows, you would have to use the nominal rate and growing annuity. So you got that? So that's the trick here. Real dollars with the real rate, nominal dollars with the nominal rate. So you just have to make sure you have those things. All you need is the first cash flow for our formula. So all you need is this one, the first cash flow. For the annuity, the regular annuity, that says regular annuity, you need just the first cash flow for this one as well. Okay, so this is part A, this is the timeline for part A, and this is the timeline for part B. These are real cash flows up here. I write 1,000. There's no special way to write it. I don't know if there is a special way to write it, but I'm just writing 1,000, but I'm putting a note up here to remind you these are real cash flows. So to discount them, in other words, to value them at time 0, we use the real rate that we refer to as a discount rate. It's really an interest rate in the formula. Okay. For the nominal cash flows, we use the nominal rate and the growing annuity formula. So what does that look like? So I'm going to show you this. I'm going to email this to you, so don't worry. Don't worry too much. Just spend your time thinking, not worrying. Going to put this into the Dropbox. It's already there. So let me save this work. So for the first one, so for the regular annuity, you need the regular rate. So I make calculation for the regular rate, and it's a lot of decimals, so you're going to store that value. And then use the time value of money keys with this rate, and you should get this number. I'm going to give you some time to make sure you can get that, and then we'll do the second part. So the most important thing was this relationship. This was new. Well, it's a correction on what you understood about the relationship between the two. It's very important that we use the factor effect of interest, the compounding effect of interest. Same with the compounding effect of inflation as a rate. Let me know when you got it. I'll wait for 5 people to get it, and then add a little bit more time. Okay, so this value is really, this is the value for real dollars with the real rate. We should be able to get the same present value, the same valuation at time 0 if we use the nominal dollars with the nominal rate. Okay, 2 more. I'll wait for 2 more people. So you should be using the TVM keys with 6 in N. After you've calculated the rate and you've stored it, 6 in N, recall 1, depending on how you stored it, times 100. equals and store that in interest. And then PV is what we want. We say there's a payment of 1,000 to be received into payment. FV, we're not putting anything in there, so there's 0 in FV. And then compute PV. And again, I'm stressing because I know many students still are not using the financial calculator as prescribed. Use the keys to save yourself a lot of time, and do not round intermediate calculations. If you round this, you won't get exactly my answer, and I will take marks off if you don't have the decimals. Okay, so quite a few people got it, all right? So you get that. Now, let's work with the, this is the second formula or understanding that I expressed in a timeline. This is the relationship between real dollars and nominal dollars. Again, nominal is what we've been using till now. When I talk about real, that's the new thing, the new concept. So what I did was I took those real dollars and I adjusted them for the number of periods of inflation that transpired. So that's the second formula for you on the sheet. And so that makes the first cash flow, this is C1, is going to be 1,000 with a growth factor of 2, but that's C1. Basically, I could also put 1,020, but I put it like that so you know where I got it from. And this all goes into, all the details go into the growing annuity formula using, notice what I use. I use the growing, the growth rate of inflation, because that's what my cash flows are growing by, a rate of inflation, with the nominal rate. Nominal dollars, nominal rate. You should get the exact same answer. Okay, so this is really precise. This is exactly what's going on. If you use if you use the approximation method, you're not going to have this much precision or this precision. So to enter this into your calculator, what you're entering is, starting here, as I told you the other day, you're going to enter (1.02 over) no, that's wrong. 1.0, yeah, no, that's right. Over 1.08 to the power 6, 1 minus and then 10, 20 in front, divided by 8 minus 2 is 6%. Now remember, you're working with decimals now to enter this. So that's the formula that you're going to enter into your calculator starting here. So 1.06 divided by 1.08 equals, then y to the x 6 equals, then make it a negative, add 1 equals, and then multiply, divide. Okay, so let me know when you got this one. Tell me, got part B, if you got it. You should get the exact same answer or result as you got above. Great. Very good. Okay. Okay, so the other people who aren't getting it, work with this. So all that's new, what is new is this, well, I don't know that it's new, but the understanding of the relationship between nominal and real dollars and nominal and real rates. So you can put those, add those to your formula sheet. So I will send you this solution. There's a second question that does the reverse. It starts with nominal cash flows, not adjusting them for inflation, and you get the opportunity to see the effect of the erosion due to inflation. Okay. Okay, so let me go back to, let me save this and go back to the question paper. So the bottom part. Part 2. So for people who are still plugging in, I'm going to give you some time. I'm going to ask everyone who's done, start part 2. Suppose the expected real discount rate is 5%. So now I'm giving you the real rate. And inflation is 1%. What is the present value of a 5-payment annuity of $500 nominal cash flows with the first payment in 1 year? So first calculate the present value using the regular annuity formula and the nominal amounts. So we have to draw the timeline. Okay, so 1 through 5, and I'm getting $500. So these, I'm going to make a note now, these are nominal cash flows, right? So this is nominal. All nominal cash flows. So that's just an annuity, right? That's an annuity. all I need is the nominal rate. The rate nominal is what I have to solve for. I know that 1 plus the nominal rate is equal to 1 plus the real rate with a factor of inflation. So I can solve for that. That's 1 point. So remember, I got this information here and this information here. So it's going to be 1.05 to the 1.01 or times 1.01. So Rn is equal to when you minus the 1, you get 6.05%. Very good. So now use that rate with the regular annuity formula and tell me what you get. I'll wait for, I don't know, a few responses. So what do you get? Regular annuity formula. So, you know, we're practicing regular annuity. With the nominal amounts, with the nominal rate. So you're going to enter into your calculator 5, actually maybe make it higher. So 5 in N, 6.05 in interest, and PV is what we want. Payment is 500, and 0 into FV. So PV is see some different answers. Okay, so it's kind of converging on 2103.32. So this one is not, it's not hard to get this correct because you have the rate and it's rounded, so you can just easily punch that in. You don't have to store that or anything. Keep going. Who else? So the people who don't get the majority number might have to check. So let me bring up solutions so it's much more tidy. Somehow I have a there you go. So there's the answer. to the decimal place. You guys did well. Okay, this is the last thing on this. This is the last question on this page, and the most I don't know how to say it. The most surprising result, maybe? So all the rest is straightforward. Once you understand part B, be no problem, but this is something new, possibly, that you haven't realized. Very good, you guys. You did good with that one. Just the people who got it wrong, just double check, make sure you can enter that. Okay, part B. Let me give you 10 minutes with part B. You know you have the right answer when you get this answer. So try to get this answer. I had to cover the answer. Okay, so try and get this answer. Begin with making a timeline. And see that you can find this result. So there's lots of algebra in this class. I can make it even harder, but I'm going to, I've left out some complicating or even more challenging exercises. But this is the minimum complexity that I think is justifiable to give you. Okay? I'm just not making it so hard because it is the summer and we don't have a lot of time. But this is feasible. This is fair. I think this stuff is fair that I'm showing you. I'm expecting you to learn. Okay, so the question is, what the heck are we doing? So the first part, to clarify, the rules, so I gave you two formulas, one for the relationship between nominal and real rates, and the other one between nominal and real dollars or cash flows. And I told you the rule, nominal dollars with nominal rates, real dollars with real rates. So this problem is given in terms of nominal dollars, so I need the nominal rate. So that's why I used this one. And that's all I have to do. They are already nominal. Do you see? We didn't have to adjust anything. They were given nominal. Not like in question one. In question one, they were given as real. That's the difference. Monica. Thanks for the question. Okay, so do part B. Now you're going to work with getting the same result but using the the real rate and the real amounts. And I make a strong note here. 1% is not, minus 1% is not the growth rate. You have to find the growth rate to use it in the formula. And the way you'll find it is using looking at the timeline to identify it. remembering that rates are multiplicative factors. Okay, it's compounding. It's not adding and subtracting. The relationship is not just, oh well, it's growing by inflation, so that's the rate in the part one. But in part two, now it's the inflation is eroding. So how do you introduce the concept of inflation eroding the purchasing power of cash flows in the future? How do you incorporate that? That's really what you're getting at in this part. And G will not be, for the growing annuity, will not be -1. You will not get the right answer. Okay, Alfonso. Yes, but not just 0.99. You still won't get the right answer if you use 0.99. You have to be even more precise than that. What I'm going to do is draw the timeline in this space, and then I'll shrink it. So the timeline goes like no, you know what? I'll do it up here. So it's so now I'm going to draw the real cash flow timeline. So what does it look like? In nominal terms, it was $500, but in real terms, inflation happened in this period, which eroded. So I have to deflate the $500 by 1.01. You see? And inflation happens in this period. So I would have to deflate this 500 by 2 periods. Why am I doing this? Because of the relationship. Remember, real cash flows. So I said cash flows nominal is equal to real cash flows the notation. Cash flows nominal time t is equal to real cash flows times t times a growth factor of how many periods of inflation have passed. So if I want the real, I have to deflate. So this is inflating, and when I divide, it's deflating. So if I want this, I have to put that down. So that's what's happening. So this is important to understand. So then this one would be 500, 1.01 cubed etc. 500, 1.014. So you get the idea. The point is, all I need for my growing formula is the first cash flow and the growth rate. I need two things. So what's C1 and what is G? That is the question. Those are the questions. So C1 is clearly this amount. So you could put this amount into the formula or simplify it, 499. It's going to be 495.05, but I prefer to leave it like this because otherwise we're going to lose decimal places. So C1 is this amount and G is what? Well, after this amount, the first amount comes, the next amount comes as the first, right? Times a discount factor or deflation factor like this. So that's what I need from my formulas, right? So my formula is always the first cash flow is C1. The second cash flow is C1 1 plus G. Again, I'm really focusing on the techniques, okay? The techniques are the most important thing to me. This technique that I'm teaching you now is useful for all the exercises, most of the exercises that I have questions about with growth. So if this is C1, then this must be 1 plus G. So that is the third formula that you're learning from this sheet. Okay? That 1 plus G is equal to 1 over 1 plus the inflation. That is the way you find G. And the answer is 0.0099, so it's almost 1%, but it's longer than that. If you just use 0.0099, you're still not going to be as precise. You need the whole decimal set. So when you solve it, here it is here. Solve G. Okay, I'm shrinking the whole thing. So this is the relation, this is the third relationship you need from this handout. So it's not only 0.00990099, it's a negative. That's really important. It's a negative growth. The amounts went down, right? It wasn't because you were only receiving amounts as nominal dollars without adjusting for inflation. In the presence of inflation, you have lower purchasing power, and that's going to be reflected in the real dollars amounts. So you can buy, you're going to be able to buy, you're only able to buy less. You're not going to be able to buy that iPad. Maybe you buy a secondhand iPad, or you buy a lower quality tablet or a cheaper tablet. but you're not going to be able to buy the exact same thing or equivalent. Okay, so that will give you the identical result. So I'm not going to say that this is, everybody's going to get this right off the bat, so don't feel bad if you don't get it off the bat. Realizing there were three things we learned: the relationship between real and nominal rates, the relationship between real and nominal dollars, and the relationship between inflation and growth. When we talked about real dollars, in terms of our formulas, we were able to use inflation as the growth rate. When we were given nominal dollars in the second part, the growth rate is going to be negative, right? The real amounts are going down when we translate them to real dollars. And this is a relationship between growth and inflation. It's a negative rate, and you should store this value to make the calculation. This is your first cash flow. It's the growing annuity formula. So let me give you 5 minutes to figure that out. I'm going to email you the solution set so you have it all nicely typed up. And I'll get back in 5 minutes. Okay, I'm back. Okay, any questions about that? Are you able to get those numbers the same? To enter this into your calculator, I recommend storing this amount. You have to be very cautious, right? Because there's a negative here. You can't lose the negative. You won't get the right answer. So you're going to go recall 1 plus 1, that'll be the top, equals, and then divide by 1.05, that's easy, equals. So that will be the inside part. Then you say y to the x 5 equals change the sign to a negative and add 1. And you're probably tempted to use your programmable calculator. I'm telling you, learn this technique, it's much faster. And then say equals. And then it's easy. Well, still you got to multiply by these and divide by, maybe you use brackets here because you have to do a recall again for the G. All right. So work with that. I sent you the clave. I think I actually put some questions on Connect with this concept, but you know, simpler than this approach. But so there are 3 formulas, just to recap. The formula for the relationship, so this is known as the Fisher relation between real and nominal rates. The relationship between cash flows, real and nominal cash flows, is by a growth factor of inflation. And finally, the relationship between inflation and growth when you have deflation, or you have, the erosion effect of inflation on your dollars. So that's it there. Okay, so 3 expressions from this one handout. All right, okay, so let's see. Let's go with review. Let's look at the test prep questions then. The other reviews, you have the solutions for those. So let's focus on the test prep questions. Oh, I also gave you that G star exercise. That's just a bunch of algebra. How's everyone doing? You're so quiet. Okay, so here are the test prep problems. I'll just do a few here and there, unless you have particular ones you want me to do. So I promise people, if you send me the solutions, I will look at them, and I'll tell you if you're on the right track. Oh, the E formula from last class, that's when you're told about continuous compounding that you use that. So don't use that otherwise. Okay. So let's see. Let's do the first few here. So you've been given an effective annual interest rate of 15%. What is the equivalent rate that's semi-annual compounded semi-annually? So what you want to find, what you're being asked for, is the effective period rate of a half. So you were given I'm going to have to make this really small. I didn't leave a lot of space here. I didn't want to send too many pages, so I made it so small. So you need that, but you've been given the effective annual interest rate. Now I can call that, I've been showing you that I call it EAR, but you could also call it EAR in my notation, in my solutions, is also EPR1. So it's an effective annual rate. That's another way to write it. So go for the smaller one. There's two of these in one of those. So these must be equal, right? And solving for what I want, it will be EPR 1/2 is equal to 1.15 to the half minus 1. And you get some number. So on the test, I'm going to tell you how many decimal places and things like that. So in this one, what did I say? I said 6 decimal places if expressed as a percent, 8 if it's expressed as decimals. So the answer I can write 7.23805. 295. Okay, you have to put them all in there, but I'm cheating. Okay, so there. All right, so that was easy. The next one. Annual rate compounded continuously. So this is a stated rate. I know it's a stated rate because it says annual, but it says, oh, sorry, no, not this one. I have to go up here. I moved into the space here. I need to erase that. Oh, I cleared everything. What's happening? All I want to do is clear this. No. All right. Let's look at this one and then the other. So I'm looking for equivalent rates, annual rate compounded quarterly. So that is a stated rate. How am I going to get that? What's the annual rate compounded quarterly? What you want to find is R1/4. So that's just taking the effective quarterly rate. I have to erase all this stuff because I can't see. All right, I gotta erase all this, sorry. Okay. Wow, I didn't know I could do that. All right, so I'm learning every day, just like you. So I want the annual rate compounded quarterly. I want R1/4. R1/4 is the stated rate. It takes the effective quarterly rate and multiplies it by 4 as though it's just the simple interest over the year for quarterly rate. So first I'm going to get the quarterly rate, and then I'm going to multiply it by 4. The quarterly rate I can get it from the effective annual rate of 15% that was given. And I know the effective annual rate, and I want to get one quarterly rate. And the way that I do that is a relationship. This is the smaller one. There's 4 quarters in a year. So that's the relationship. So I need to take 1.15 to the power of a quarter. So I'm going to partition it into 4 equal parts. I want one of them. And then minus 1. That will give me the effective quarterly rate. Based on this relationship down here. Because this one was 1.15. And then that result you multiply by 4. So the quarterly rate, 1.15, to enter that into our calculator, remember? Geez, I really have no room. I'm going to have to I'm going to just introduce new pages, blank pages, to do this. So EPR 1/4 is equal to 1.15 to the quarter minus 1. To do that, you write 1.15 y to the x for inverse, so you get the 1/4 and say equals, and then minus 1, and you get the result 3 point, well, I'll put it in decimals, 0.03555580763%. And the final step, once you've got that, R 1/4, as I explained, is 4. So you take your effective period rate, which is really what you're paying in interest every quarter, and they just want the simple interest rate. So you multiply that by 4, and you get, so I'm going to, no, that wasn't percent, sorry. That was decimals. Let's erase that. And in decimals, this would be 0.14222323. Oh, 54%. Okay, so that's, or you write it as 14%, 14.22323054%. Oh, I did it again. This is not a percent, that's decimals. Okay. So messy. Hopefully you'll be neater. Okay, so now I'm going to get to the continuous compounding problem, the next one that you've all been waiting for. What is the answer for the third one? What do people get? So now we're here. The annual rate compounded continuously. I explained to you last class the relationship between continuously compounded rates. Continuously compounded rates are stated rates, and it's true that ER0, the continuously compounded rate, is related to the effective annual rate like this. I showed you the string of equalities and rationalized how I got this, and was counting on you believing me that this was equal to that limit expression. Because what I'm being asked for, and I already have this, right? This is 15%. What I'm being asked for is this part. How do I get there? I gave you a second formula to solve for that. So to get to the exponent, you need to take a logarithm of each side. And because this is an e, you take the natural log. So R0 is equal to the natural log of 1 plus EAR. So your answer would be log of 1.15. and you end up getting $13.97 blah 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 percent. All right, so that's not so hard. That's it. That's the extent of understanding continuous compounding. The concept is that it relates. This is the relationship between the effective annual rate and the continuously compounded rate. So you can use this form of the relationship or this form of the relationship, depending what you want. If you want to convert from the continuous rate to the effective annual rate, you do it this way. If you want to convert from the effective annual rate to the continuous rate, you do it like that. So there's two expressions. Very good. Okay, how about this one? Everything seems new, right? But at least you have all these documents to reference when you write the test. I'm not taking anything away from you. I'm expecting a lot. I'm not denying that, but I'm not taking any of this away from you. All your hard work, you get to use it for the test tomorrow. So, what about the annual rate compounded every decade? Again, that's a stated rate because these are different. It's over the year, but it compounds every decade. How would I even write that? So remembering that the subscripts are denoted in terms of a year, a decade is 10 years. So it would be like this. I know it's weird, but it's using the same pattern. Same pattern. It's not a fraction of a year, it's more than a year. And how would I figure it out? How would I figure it out? I would have to multiply. What am I multiplying by? What am I doing when it's a decade? So remembering the stated rate is always the effect, it's the simple interest over a year. So the effective rate would be, sorry, I didn't write that right. The effective rate would be the 10-year effective rate. But the stated rate needs to be the simple interest over a year. So there's something missing here. These are not the same. What do I do? Yes. So this is, so everybody, this is the 10-year effective rate. This is as though it's just one rate for 10 years of accumulation. So where it's 15% every year, the 10-year rate would be 1.15 to the power of 10. That's what that is. But the stated rate needs to be over a year. It needs to be stated annual. So what I have to do is take the 10-year rate and I have to divide it by 10. I know it seems weird, but when you think about it, it's the pattern. Okay, so now the subscript is not a fraction. The subscript is a whole number. So I have to scale this down to a year by dividing the 10-year rate by 10 back to a year. In fact, the formula that I gave you still applies. This is the number yeah, let's just say, if you look at the formulas I gave you, this still applies. So I think that's the only kind of, these are like the things that you have to think about. Well, this one was straightforward since yesterday I taught you this. Now you got to think about this a bit. Okay, so usually what we say is the stated rate is equal to, where it's always a fraction, right, is equal to the effective rate times how many periods of compounding in a year. That's the formula, and I put it either I solve for EPR, where I take the stated rate divided by this, or with EPR I can calculate the stated rate by multiplying by this. And then I told you that this was equivalent, where the n was usually was the fraction, 1/2, 1/4, 1/12, 1/365. This was the inverse of that. So just like that, this is the inverse of this subscript. All right, so that's something new, I guess, for you, but that's still using the same formula. Okay, so essentially the best way is to understand this than using formulas is think, well, I want to have the simple interest over a year for a 10-year rate, so I have to take the 10-year effective rate and divide it into a year. Because it's stated as 10, it's compounding in 10, I have to divide it into 10. Remember, simple interest is a multiplicative and dividing thing. Okay, so then I start, so all those exercises in number 1 were given an EAR, find some other things. Now we're going to get, if I give you a stated rate, how do you find these things? So let me just run through what you're going to be looking for. So for this one, you're looking for the semi-annual rate compounded semi-annually. Those are the same. Okay, so it's the same, it's stated over the same amount of time that the compounding frequency takes place. So what you want here is EPR 1/2. Given, what's given? Given the stated rate compounded semi-annual. So you're given R 1/2 of 12.5%. So we know how to do that. To get from the stated rate to the effective rate, this is just the simple interest over a year of of two periods of compounding. So all I have to do is take that. So this is like a bond. This is like a yield to maturity. I need to take that and divide by 2. So that one was easy. Most of these are easy. There's some challenges. Oh, I didn't give you the answer for the one above, did I? I should go back. But okay, let me finish this. So this is just 12.5 divided by 2, which is going to be 6.25%. And then okay, you guys haven't said anything. You want me to go back to that one? I didn't finish that one, did I? I was talking so much. Okay, so this one, for this one back here, what you have to do to find R10 is take the 1.15 to the power of 10 and then divide it by 10. That will give you the answer. And the answer will be 30.455555. Three fives and 7. Okay. No comments from you guys. You all watching? Who's watching? Okay, still some of you watching. All right. Annual rate compounded quarterly. So what I want here is annual rate compounded quarterly. That's a stated rate. I want R1 quarter. To get R1 quarter, I need to have EPR 1 quarter. To have R1 quarter, I need EPR 1 quarter, and I have to times it by 4. So those are the steps. I'm going to have to get EPR 1 quarter and then multiply it by 4. How do I get EPR 1 quarter? Well, this is a 4. Let me write that again because R1 quarter is equal to EPR 1 quarter times 4. So to get EPR 1 quarter, I could, so for all these exercises, it might be worth it, like the first one, starting with an EAR. So maybe we can convert the last one to an effective annual rate because they're all related, and then use it over here. Or why don't we just use the relationship between the quarter and the half year rate? So what am I talking about? It's true that I need EPR 1/4, and I'm given EPR 1/2. What is the relationship between these two? Well, they're related through the equivalency like the equivalent string of equalities that I shared with you. Which one is smaller? Quarters are smaller, and there's 2 quarters in a half of a year. Okay, you guys are still on the other one. Okay, I'll go back. I'm going to pause here. Let's go back, because you were asking me questions about this one. Yeah, that's what I did. Somebody asked me, do I put it to the power of 10? Yeah, that's what I did. I put it to the power of 10, and then I multiply by 10. I mean, multiply by 1/10. That's how I got 30. So let's see. So let's go back. So sorry for people who are ahead, but I'm being pulled back. So 1.15 to the power of 10, and then divided by 10 equals what did I do wrong? I have to I have to hold on. I forgot to minus the 1. That's all I screwed up here. Okay, I went too fast. Okay, let's do this one again. I'm going to do, I need to work on a separate sheet. All right, so I'm going back to this problem. So what's the relationship between the effective annual rate and the 10-year rate? Well, there's 10 periods. Nope, that's not right. Which one's smaller? I have to redo it. Okay, do that again. So I want EPR 10 and I have EAR. What's the relationship? And start, which one is smaller? This one is a smaller one. 10 years makes a 10-year equivalent rate. So I have to take 1.15 to the power of 10 and then minus 1 to get EPR 10. So that gives me, I'm rushing too much, I have to slow down. So to the power 10 minus 1, so this gives me 3.0455 7736. Now that's a decimal, not a percentage. That's a decimal, not a percentage. So when I go for R of 10, R of 10, I said, would be equal to EPR 10. So that's the 10-year effective rate. But I need to scale it down back to a year. Even though there's a 10 here, that's representing the compounding frequency, but I need to state it over a year. That's what R refers to. So I have to multiply it, I have to divide it by 10. So when I do that, I get when I do that, I get the 0.3045577736. All right? And that means the answer is 30.45, you get the point, blah, blah, blah %. I have to give, in the final answer, you should show me all the decimal places I asked for, but I'm just shortening it not to make a mess on this page. So that's how you get it. Is that better? Yes, Alfonso, you have to minus the 1. I did not write that down. I'm taking off the principal. All right, so what's next? I left off here. The half-year rate that we computed in the first part of question 2 was 1.0625. Well, it's 6.25, but this would be 1.0625. So what's the relationship between these two rates? Which one is smaller? The quarterly rate is smaller than the half-year rate. 4 of these and 2 of these would make 1 year, but why don't I just relate them to each other? 2 of these would be 1 of these. So to solve for the quarterly rate, I would have to take the half-year rate, divide it or partition it into 2 parts, minus 1 to find the equivalent quarterly rate. So when you do that, you get 0.0307764.64. Are we finished? No, because what we wanted, what we were looking for, was the stated quarterly rate. So now we can find it where the stated quarterly rate is 4 times the effective rate. So it just takes the effective rate and it multiplies it as though it's just reporting the simple interest over the year. So when you do that, 4 times that amount gives you 12%. So it's going to be 0.123105626 or 12%. Okay. What's next? And then the annual rate compounded continuously again. So now for the next part, so for problem Now I want here R0. How do we find R0? We have the two expressions. R0 will come from the effective annual rate. Remember, R0 is equal to the logarithm of 1 plus EAR. So that means you need EAR. You need the effective annual rate to do this. You have a few things you can use. You could use the quarterly rate, you could use the semi-annual effective rate. Let's stick with the semi-annual effective rate because that's an easier one to write down at this point. So I'm going to add another page. So what I want to do is R0 equals log of 1 plus EAR, and I explained yesterday where I got that from. So I need EAR. And I have, in the first exercise in the second question, is EPR 1/2. The relationship is that which one is smaller? The semi-annual rate is smaller, so 2 of these equals 1 of those. All I have to do is take the rate from the 6%, $6.25, squared minus 1 will give me EAR. And once I have that, I put it back up here. So when you solve this, this turns out to be 0.12890,625. And you keep the decimal places, of course. And then you put that, you can store that. And then say R0 is equal to log of 1 plus that. Or you know what I'm going to write? Recall 1. Okay, so you recall, you add 1, you take, say equals logarithm, and you get the answer. And your answer should be 12%. Okay. All right. Should I continue with these? I'm going to get into the other exercises. So you continue with this. There's nothing too hard in the next part. And the last part, part 3, I give you the annual rate compounded continuously, and you work from there. So let's just set that up. So lots of practice with the annual rate. Some people wanted more practice. This is it. You know, you just need to know how to convert it to the effective annual rate to work with it. Let's see what we need. So we're given R0 here. You're given R0 equals 12.5. And we want to find, okay, let's write down, this one is for the first part, you want to find the rate per year compounded daily. So because it's over the year, but compounds daily, it's an R. So you want a stated rate of 1 over 365. So that's that one. The next one, you want the rate per month compounded monthly. Those are the same. So it's an effective rate. You want EPR 112 for that one. And for the last one, you want the rate per year compounded every 2 years. So this is like the decade one. So what you want there is R as well. But the subscript is not a fraction of a year, it's 2 years. So that's what you have to get for those. So you guys really want the solutions for this, right? I feel like I should give them to you, but I really need you to work on these on your own first. Okay, so I guess I'll send you the solutions for these, but keep on deriving your own solutions. But this is it. Basically, I'm gonna give questions on the test like this. So you're gonna study this for the next 2 days, and then write the test. And as I said, I'm giving you 9 hours for the test, so I'm not too worried. You shouldn't be worried. Just keep studying diligently and asking me questions, and you'll get through this. Okay, so I'm going to leave this. You work on those, and I will send you the solutions. Let's get to the next set of problems. All right, so what are you supposed to do here? Bristol Myers Squibb has a bond. So people ask for bond questions. You got everything in here. $1,000 face value bond with 22 years to maturity and 7.2% coupon, paid semi-annually, recently sold for this amount. What is the return on this bond? So you have here, you have the information on the face value, which usually is 1,000, which is going to be 1,000 for this course, with 22 years to maturity. Remembering bonds are paid, look, I put it in brackets for you, paid semi-annual, so you know that the rates that you're going to get are stated. So this is 7.2, we need to convert that. We need to convert the years to semi-annual periods, and we have a price here. Look at that, we have all this information. So we get to choose between those results. Wow, look at all those options. So let's see. So we're going to take the basic, we're going to change this to 44 semi-annual periods. And then we're going to change this to the coupon rate to find the payment. So payment, actually I don't want to put it there because I need that for, I lost the little thing. Oh well. Oh well. Okay, so payment is equal to 7.2% divided by 2 times 1,000, correct? So the payment is going to be $36. You know how to get that? How to plug that in? Well, I'm talking, when I say next 2 days, I mean today and tomorrow. The exam is tomorrow. Yes. So you have 2 days to study because you have today. Some people are just getting up right now. I mean, you guys aren't, but the day is young. The day is very young. So that's $36. So I have everything I need, right? 44. So I'm going to put into my calculator 44 goes into N, and then well, actually, before I do that, I have to write the formula, right? You need to show me your work. I want to see your work. Even though I give you some options to choose from, I want to see your work. So the formula is going to look like present value, the price, and the price was $163.66 equals $36 divided by the effective semi-annual rate. I just have to write slower and I won't make so many mistakes. So this is the annuity piece of the coupons. And then don't forget the lump sum at the end, the face value of the bond is 1,000 discounted 44 periods back with the semi-annual rate. So what we're looking for no, I didn't want to get rid of that. Okay, ignore that too. What we're looking for is that EPR. This is what we want. So we put this into our calculator properly. We put 44 into N from left to right. Next comes interest. We don't put anything. Then we put into present value. This is what you have to pay. Make it a negative. it's a negative cash flow. Then you put into payment 36 as a positive and 1,000 as a positive for face value. You enter something into all the values and then you compute the interest rate. So what you're getting out of your calculator is this. Okay? So your calculator will tell you that the rate is 3.32264. Okay, so if I want 8 decimal places, 1, 2, 3, 4, 5, 6, 7, 8. Actually, I didn't have to put that many, but okay. So that's what your calculator tells you. I'm just indicating you should store that value, okay, because you don't want to lose the decimal places. So store 1. And what are we going to do with that? That's just the semi-annual rate. So let's look at our options. That's the effective semi-annual. So there it is. That's it, the first one. So A is correct. So A is correct, but there's so many other alternatives. Let's read through if any of the other ones suit. So A is correct. So the answer could be A. Or it also, there's one here that combines A and E, so I'll have to check that. And this one combines A, B, and E. So let's just check B and let's check E. Do you follow my logic? I'm not going to check all these things. I'm just going to check the things I need. You have to be efficient with your time. So I know it's A. I'm convinced, I'm positive it's A. So either it's just A, or it's A and E, or it's A, B, and E. So I need to check E, and I'm going to check B. So what does B say? B says per year compounded semi-annual. So this is what they're suggesting is the stated semi-annual rate. So this is R 1/2. You can't really see that, can you? So this is R 1/2. Is this R 1/2? How would I check? Well, this is the stated rate taking the effective rate times 2. So let's write that down and then check it. So the stated rate is 2 times, it's just the simple interest version over the course of a year of the semi-annual rate, effective rate. So we got to take the one we got that we stored, the 3.322649999, and times it by 2. Do you get that? 6.64? Yes, you do. So this one is also correct. Now we just have to check E. So to check E, this is per year effective. So this is EAR. So we got to verify if this is the effective annual rate and we compound it for 2 periods, will it be this? -1? Minus 1? So let's again take our value, 1.0322649999, and you put it to the power of 2 minus 1, do you get 655? let's see. Yes, so you get this too. So these are all correct. These are all correct, so the answer is I, A, B, and E. So those are all correct. How's that? Very good. Okay, so this is it. This is the idea. Just you need to do everything at once. You got to be good at all of it. Okay, the interest rate conversions are very important. We did spend 2 days on it. Okay. So let's see about, we looked at bonds. Let's do a couple of stock problems, because there's some things I need to tell you. Then you have some more mortgage problems. There are 20 problems on here, right? Some more pension problems, lots of bonds problems. And, okay. So let's look at this, a few stocks. So I wonder if I can cut this. Can I cut this out? No. That's not what I wanted to do. Ooh, that's not what I wanted to do. That's interesting. Sorry, I'm having way too much fun on my... I have no idea how to get rid of that now. Okay, I'll play with that later. Okay, what I want to do is solve this one. An investor is considering to purchase a stock in ABC Incorporated. Knowing that stocks of similar risk have an effective annual rate of 12%, ABC is expected to pay quarterly dividends, with the first dividend, 0.75, occurring in 6 months. Each subsequent dividend will be 1% greater than the previous one. All right, so there's lots of stuff in here. We have to use our steps. So step 1 is, when are the payments? Ask the questions, when are the payments? Payments are to be received quarterly. Now you have to remember this. If you didn't learn it in 3106, I'm telling you now, in terms of stock, if you purchase stock today that's paying a dividend today, you're not entitled to that dividend. You have to wait. There's a waiting period. So dividends will accrue to you and will be relevant in your calculation only if they're coming a month or more from now. Okay? So having said that, information about past dividends can help in computing what future dividends will be. So you do need that information for your timeline, but it might not be those dividends that you're going to be, you're going to use the information to compute what the dividends of the future will be. However, you don't include past dividends in your computation of the value, the present value of current future cash flows. Okay, so that's all this is. So stock is valued depending on expectations about future returns, and this is constantly updated. Okay, and the stock market constantly uses available information. So Bloomberg is a news agency. I mean, that's how Bloomberg was just collecting news, and then it's been using that news to to do all kinds of things over the past 40 years to help people, analysts, make predictions about what future dividends or earnings would be, and that would help them in stock valuation. Okay, and now there's information in there on all kinds of derivatives and on fixed income bonds. So all that information is just information. And with some finance knowledge, information can be converted into valuations, and that's what you're learning how to do. All right, so the dividends are quarterly. The first one that you're entitled to will be 75 cents occurring in 6 months. Each subsequent dividend will be growing, so they expect the company to be growing. So these all have to go into your timeline and valuation. So I'm going to draw a timeline. The rate that we're going to need is going to be the quarterly rate because the payments are quarterly, but we're also going to have to be aware that there might have to be adjustment. Well, it's 6 months, so that's just two quarters from now, isn't it? 6 months is 2 quarters from now, so that's helpful. Remembering as long as things are happening in quarters, we don't have to worry too much. So let's draw this timeline. So it's going to be 0 here, and then I'm just going to mark in the months. So this would be quarter 1, or 3 months. Oh my goodness. And then this is 6 months or 2 quarters. And then the next quarter will be 9 months or 3 quarters. Q for quarter. And so the first one is coming 75 cents here. Okay. And then after that, and we assume because corporations theoretically can exist forever, owners of stock can sell stock, or they can bequeath, like they can give their stock to their beneficiaries when they die. So technically ownership can continue indefinitely, and so corporations can continue indefinitely. So we use that in our valuation and assume that the corporation exists forever, and so our revenues or our dividends will accrue forever. And we're expecting that they're going to grow. This one is going to grow indefinitely, so its returns are going to grow indefinitely, like forever. So you're told that they're going to grow at 1% forever, right? So this next one is going to be %1 greater. and so on. So what you have is the pattern for a growing annuity with the value here. I'm going to say 1/4. Or Q1. Okay, so the first quarter. So you could get the value of this perpetuity. Did I say perpetuity? I meant to say perpetuity. And it's going to be with first cash flow, right? So the formula is C1 over I minus G. So more specifically, this is the first one. The I is going to have to be the effective quarterly rate, and the G we already know as 1. So we need to compute the effective quarterly rate to solve this first part. And then, since our final answer should be PV0, we're going to have to take that amount, whatever we found, and discount it 1 period. Okay? Okay, so do that and send me your answer. Who did this already? First of all, let's get the EPR 1/4. EPR 1/4, if you don't have that right, you're not going to get the right answer. So EPR 1/4 is going to be determined by taking the annual effective rate of 12%. So you're told that the effective rate is annual. So that's going to be 1.12 to the quarter minus 1. So you're going to store this value that is 0.02873734. Okay, so store that so you can use it. Okay, someone's put an answer up. Anybody else? So you're going to put that in here and find the price today, at 3 months, and then you're going to discount that 1 period. You can use the financial keys for that, or you can just use brackets if you like. Okay, I have 2 answers. Anybody else? Very good. One more person. Anyone have a different answer? Okay, you guys are all right. Very good. $38.91 is the answer. So when you do all of this, you get $38.91. Good. Okay, so we have a half an hour left. Well, not really, but I could stay on for half an hour. I would like to do, very good, Monica. I would like to do, I don't know, do you want to look at G star or do you want to continue with these exercises? I will send you the key for these because I feel so sorry for you. And I feel sorry that my notes are not so neat and tidy as they are in the documents. I mean, my iPad markup. So do you want the G star problem explained, or do you want any of these explained to you? Alex, you want me to stay here? Okay, so I was looking at doing the birthday problem. The 25th birthday pension problem. Do you have another preference? You guys don't care? No comments? All right, I'm looking at number 10. I'm looking at number 10. Monica wants 7. Okay, let's see. What's 7? The mortgage problem. Okay. We can do the mortgage problem. So let's do 7. Okay, so Chris 2. All right, let's do 7 then. All right, so refinancing. Okay, you wish to obtain 1,000. Was this this is refinancing? Yeah. Okay. So, you wish to obtain a $112,000 mortgage from Banco Popular and are offered a rate of 7.75% per year, compounded semi-annually for 20 years. Monthly payments start 1 month from now. So right off the bat, monthly payments. I need the monthly rate. But I've been given, they haven't even given me, they've given me a weird rate, right? I've been given a rate that's stated semi-annual. So usually it's stated in the United States and Puerto Rico, it's stated annually. They're stated monthly. But in Canada, they're actually, in other countries, they're actually stated like this. So that's a mess, isn't it? The reason they justify doing that is because if all banks state them the same way, they could be comparable, right? So as long as one product, like a mortgage, is stated the same across the board in all financial institutions, then you could compare the rates. So the simple interest stated rate is R1/2, and it's stated as 0.7, no, that's not right, 0.0775. So I have to first do the immediate conversion I can do to change it to an effective semi-annual rate, but I'm not done yet. Once I do that, hold on, I'm just looking for the problem. In my notes. Okay. So that's going to be 0.03875%. But that's not the rate I want for my calculations. I need EPR. Let's use a different color. So I have to continue doing a conversion. This is awful, isn't it? But this is what you got to do to get the right rate for the formulas. So you need EPR 1/12, but you're given EPR 1/2. So look at this. Which is the smaller one? The smaller one between the two is the months, right? There's 6 months in a half of a year, so the relationship is there's 6 months in a 6-month period. So I need to take that rate Did I just put a percentage on that? Oh geez, why do I do that? This is not a percent. This is a decimal. Sorry. Get carried away. So this is 1.03875 to the power of 1/6 minus 1 is equal to a monthly rate. Can you see that? Okay, so now we're ready. Well, we got to plug it in. So when you punch that in, you get, and you should store it, right? All this work. Don't lose your work. Store it. So since we're dealing with mortgages, you should store it, and we're going to use the TVM keys. We should store it as a percentage, but it's up to you. So this is going to give you 0.00 small, right? It's monthly rate 635646. So you can store that. Don't forget to multiply it by 100 though if you put it into the TVM keys. I'm going to do it that way because that's what I've been doing so far. Maybe you're in the habit now. All right, so next, I set up the mortgage. The mortgage that I want, or what they want, is $112,000. How about that? And that is equal to an annuity. I'm just going to say recall 1, which is fine. I don't mind. Well, it's actually, I should just put, sorry. I should put EPR 112. I'm not going to put out the whole number. That's so messy. Don't like it looking so messy. Do that again. Okay, EPR 112. And then it's an annuity, so 1 minus 1 over 1 plus EPR 112 to the power of what? It's how many years? 20 years for 12 months a year is 240 months. So that's what I put in the formula. All right, so entering this into the calculator. So that's all you have to write. Well, you have to show me your calculations for the rate. And then just write that out and show. You don't have to do any more algebra unless I ask you for, but it probably won't. Entering into your calculator 240 into n, and we have PV, so we put 112,000 into PV as a positive because you borrowed the money. And then payment is what we want, so we won't put that in. Then, oh, I missed the interest. So you have to use recall 1. Let's do that again. So you're going to say recall 1 times 100 if you use the decimal version equals, and put that into I. And then PV of 112 as a positive, and then no payments, that's what we want to compute. And 0 for future value because that's not what we're interested in right now. And you ask to compute the payment, and you get the payment of $911.03. Right? So now that you have that, you can do the second part. The second part, 5 years from now, so after your 60th payment, you have the opportunity to refinance the remaining 15 years of the mortgage at 5.5% per year compounded semi-annually. We have to do another conversion. Assuming you decide to refinance, what will be your new monthly payment? All right, so remember last class I showed you how to figure out the remaining balance. So after 60 payments, from 240 payments, after 60, 180 remain. So you have 180 more payments to make. So that means you can figure out at PV 60 what balance remains with the bank. So you're going to use the payment of $911.03, okay, because it's a dollar and cents payment that you make in the annuity formula. With here you have your EPR 112 that you computed. With 180 payments, and you can figure out your outstanding balance. So what's the outstanding balance? So you enter into your TVM keys. Here's your 180. PV is what you want. So what you're saying, the interest is recall 1 times 100 equals, put that into the interest. And then payments are 911.03 and 0 into future value. And you ask for the present value. Good. Nope. A little bit off, Alfonso. A little bit off. Remember to use the stored value. The bank will. No rounding. Brenda, yes. The payment should be in dollars and cents. You don't have to store the payment. You just need to store the rate. The payment is just the 911.03. Those decimals don't have to be stored because payments are made in dollars and cents. The one that has to be stored is this one. So try that. So the price, the principal remaining is going to be $97,511.11. And we're still not done because this is just the balance. Now we got to figure out the new payment with the new rate. So we have to do all those steps again about converting. We have to convert to get the new effective monthly rate for the new equation. So I'll wait for you guys to get that. Go back and make sure you have the right interest rate. Let me see. The interest rate up here was all the way up here, see? This should be stored. And keep track if you multiplied it by 100 already or not, okay? If you already multiplied it by 100, then you don't have to multiply it by 100 again if it's already stored as a percentage. So, okay, so if you didn't get any of that, you're confused, just stop doing what you're doing and let's continue from here because it's all good practice. So let's say this is your new amount. So let's figure out the payment on this amount. The new rate will be 5.5% compounded semi-annually. It's brutal, but that's what they're going to give us. So it's a lower rate compared to what we started with. So maybe because the terms of lending changed or the person's credit score increased, right? Your credit score improves so you can get a better rate. So this is a lower rate for you. So what we have to do is first convert it to an effective, the immediate effective rate, which is the semi-annual rate. So we just take the original one, and it was just the simple interest. We divide it by 2. So dividing it by 2 makes it 0.0275. We're still not done though, because we need the effective monthly rate. That will be found by doing a conversion. The monthly rate is going to be, well, let me do it the slow way again. So we need, given, you need the effective monthly rate given the effective semi-annual rate, and which one is smaller? The smaller one is the monthly rate. So we take it and think, well, there's 6 months in a semi-annual period, so these must be equal. So now you can compute that 1.0275 to the power 16 minus 1 gives you the effective monthly rate. So I know every day you're missing, learning something new. But they're all related things, so hang in there. So when you get this number, store it. This is the new rate. The new rate is going to be 0.0045368 with many more decimal places, but store it in your calculator. I'm going over top the other one. I don't need that one anymore. So now this is the stored value. And the new equation is PV0, PV60 equals C61, the first payment after the new mortgage refinance loan begins. And I could call this the new EPR 1/2. 1/12, sorry. So that's what you would write down. You could put a star or something here, say this is the new one. You don't have to. I'll be able to follow. The TA will have to follow what you did. Okay, so that's the new one. And so to enter this into your calculator, also the loan will be in dollars and cents, so you can use the PV from that we calculated before. You tell the calculator 180 periods with 97,511 as the principal amount. Sorry, I always forget the interest rate. Let's do that again. Interest rate. We're going to recall 1 times 100 equals store 1. Am I doing? Not store 1. Into I by Y. And then 97,000 511 11 into PV and 0 into FV, and finally compute payment. What do you guys get? Brenda gets it right. 79, 793, 54. Well, if there's any issues, please let me know. We're getting to noon. It's 12 o'clock. I will send you most of these solutions, maybe not everything. I'm going to go through. I'm going to send you at least the ones that I did solve nicely and neatly. And I don't want to give you everything because I don't want people copying. Very good, Carola. Very nice. So you guys are good. Very good. You're doing well, okay? And with all these materials, keep yourself organized. Don't be distracted in the next couple of days. And you can celebrate after the first test. All right, so have a good afternoon. Keep me posted if you have any questions for clarification. I'm going to send, like I said, most of the answers to this document. Okay, we'll talk to you. Well, I don't know if I'm not going to talk to you. I'm not going to talk to you until Monday unless you want to speak with me or by email. Okay? Take care. Have a good weekend. Bye.